Acceleration describes the change of velocity, but it's not dependent on velocity itself. So if an object is moving 20 meters per second and accelerating, it's not really any different, the amount of force that is needed to accelerate it by 5 meters per second squared, as if the same mass of an object is at rest and you want to accelerate it that same 5 meters per second squared. The same amount of force is required. So we have a problem where a student throws a metal sphere which follows the path shown above. If air resistance is negligible, which of the following is a correct relationship between the magnitude of the acceleration AK, AL, and AM at the 3 points shown? So I can just show a picture of what I'm talking about. So we're trying to tell the relationship between the acceleration at these 3 points. So first let's draw a free body diagram of this object. So once it's thrown and in the air, the only force acting on it is gravity. It may be moving at a certain velocity in the x direction, but that stays constant because there are no forces acting on it there. So if we drew a free body diagram of this metal sphere, this would be it. There's only one force acting on it. So because of this, this force is constant because mass is constant and gravity is constant. So the force on it would be constant throughout its path. And we know that force is equal to mass times acceleration. So acceleration is just equal to force over mass. So in this case, acceleration is just equal to gravity, and this is kind of how I got there. I subbed mg in for force, and the m's cancel out, and we're left with g, which is just a constant. So that means that acceleration is constant throughout its whole flight path. And so AK is equal to AL and AM. So this is answer A in question 20 of the AP test.